Okay, we're going to look at the idea of concurrence of lines given position vectors, and concurrence means that we have at least three or more lines meeting at a single point, and it's like an extension of the idea of intersection. On that note, make sure you've watched the previous video on the intersection before you've watched this. So intersection of lines given position vectors, that was given position vectors. So that was the previous video, because this shortcuts some things that shouldn't be shortcutted, only to save time on the video, and those things come from the previous video. Let's look at the example. This will help us learn what's what. We got find the point of concurrence of the following three lines. So yep, it's three lines, and if they all meet at a single point, they are concurrent, and we have to find the point. So what we do, we can deal with two of them at a time. So what I'm going to do is deal with line 1 and line 2, and we can use the method from that previous video to find the point of intersection for those. Now these are straight lines, so if they intersect at all or are concurrent at all, it'll happen once. So just be aware, as I said, some of the working has been shortcutted, and watch the previous video for the full working. So from lines 1 and 2, we can basically come up with two equations. And the two equations we've got, looking at our components there, -2, this is the I components, -2 plus t, so that's the I components there for L1, and that will equal SI. So in other words, it's just S. So S equals -2 plus t, might call that equation 1, and we're going to generate an equation 2, and we can look at, for the J components, we got 1 plus t, so 1 plus t equals, we've got on the other equation, we have 2s, so 2s plus 1, or 1 plus 2s. Now again, to cut a long story short, you can solve that just using the method from the previous video, s equals 2, t equals 4, and then we can sub that into one of the position vectors, it doesn't matter which one, and we will get the point of intersection. So you can sub it into R1 or R2, and if you like to be careful, you could sub it into both and get the same answer to verify what you're doing. I'm going to sub it into R1, and we've got, when we've got S equals, well, we don't need to worry about S, only t. So subbing in, we've got -2 plus 4i, and then for J we have 1 plus 4, which is 5j on the next line. So let's tidy that up. That is 2i plus 5j. So that's suggesting that the point of intersection, because it's got a position vector, 2i plus 5j, is the point 2, 5. By the way, while I think of it too, this whole concept can be done with 3 dimensions. This has just happened to be a 2-dimensional example. Now, going back to our general strategy, we've seen that L1 and L2 intersect. Now we need to show that L3 has that point on the line. If the point is on the line, i.e. this point, if that exists on the line, it's on all 3 lines, and because they're straight lines, that must be the point where they're concurrent, where all 3 meet. So if the first 2 intersect at that point and the third one also goes through that point, all 3 are concurrent, being straight lines. So here we go. Let's just check that out. So the point 2, 5 has the position vector we just found before, and we must make that equal, because if there is a solution to this, it's on there. Okay, so we make it equal to line 3, which I've just entered there, and we see if there's some solutions. Okay, so we check that out by creating components, as we've done earlier in this video and also in that all-important previous video. We can find that U does have a solution, U equals 2. Or you could just think about it a little bit more instead of trying to solve them simultaneously, because there's only one unknown, and so U equals 2. There's two ways of looking at that, by just purely rearranging equation 2 or solving equation 1. So only one unknown, so simultaneous equations aren't needed. So since a solution exists, we have a solution. Okay, since that exists, we can say that the point 25 exists on line 3, and the final conclusion, therefore L1, L2, L3 are concurrent, and they are concurrent at the point 25.